Okay, so you saw where we were on the Quasi Ti build. This is a normal Spica setup. Now, these Spica setups are actually quite elegant when you think about how complicated the mechanical connections are to this to make sure that it maintains a one-to-one ratio of fuel advancement and throttle body opening. That is a critical measurement, and it's also something you don't have to normally think about when you're dealing with the fuel injection on a modern fuel injected car. If you look at the gas pedal in your car, it's nothing more than a air pedal, which is what it is in the fuel injected car. The only ratio that needs to happen in those is literally butterflies opening because fuel pressure is a constant and it delivers no matter what. But in these early Spica setups, there is a far more complicated ratio that needs to be worked out. This arm and this arm advances down to the throttle bodies. This arm goes all the way down to the mechanical advancing of fuel delivery on the Spica pump, which is down here. So as the throttle is moving, throttle bodies and the fuel delivery is moving in a one-to-one ratio. In other words, throttle bodies aren't opening before fuel delivery happens. Okay? Again, that's something you don't have to worry about in a modern car because it's only one linkage going to one item, and that is it. Okay? So, when you're trying to incorporate something like this into a non-fuel injected car, it gets a little tricky. Okay? Because we're not using the Spica throttle body assembly like this. We're using the TWM throttle bodies on a early carbureted manifold. You don't have this all worked out for you in a nice math. And there have been a couple of different approaches to this, and quite frankly, I don't care for them. And I don't think that the ratios are correct, or actually, I think they're far from being correct, and I'll show you one in a minute. And I'll show you what we're going to do to work that out to a far more simplistic, hopefully substantially cleaner in appearance on the Quasi Ti motor. I want to get this worked out now because by the time I'm ready to put the motor into the car, I don't want to have to try to deal with this with the motor on the inside of the car versus dealing with it now on the outside. Okay, so here is basically the same setup that's going to go in Quasi. What is different though is, I don't know how well you can see this, there is this really articulated, complicated setup that's over the top of the throttle bodies in this particular car. And quite frankly, I don't think this is going to work very well. Because the way this is set up, the arm's right here, the throttle linkage goes all the way down to the Spica fuel injection pump to deliver fuel to the lines. However, the linkage from the throttle bodies is over here, and it's coming back on an angle to the pump, which means by the time the pump advances around where the apex on the arm comes around, only then does this start to open up. So these aren't synchronized is what I'm trying to say. So this isn't moving yet. I want you to watch how much this moves before the throttle bodies open. Now the throttle bodies are about to open. You see how much travel that is? That's a good half inch of travel before the throttles actually open up. That's not going to work. Not to mention, when in full advance in this particular setup, the throttle bodies aren't completely open. The linkage coming from here is actually touching the motor mount, which is holding this slightly closed even more so. And the bigger problem through all this is the distance between here to here. This is the gas pedal. Distance from here to here is not one-to-one in the relationship to this. In other words, you have too many different angles tying to one central advance point, and when you have pipes, and when you have connectors and cables all going to a fixed position from different angles, you will never have synchronicity, if you will, between here, down to there, and there, down to there. It's just too much. So we got to clean it up, make it a simpler approach. And it's not that difficult. It just requires a little thinking. And I think we've got a good answer. Because again, the travel distance between here to here, you realize that much movement on the pedal, is huge when you get over there to where your foot actually is resting. Could you imagine you're pressing almost halfway down and you haven't even introduced gas yet? It's a big problem. So anyway, I'll show you what we're going to do on the Quasi motor, and then we'll probably come back and change it out on this one as well. Okay, so here's our brand new speaker pump, completely rebuilt, and it's also a very advanced speaker. This isn't your normal speaker setup. It's built for a very high output on this motor. So anyway, there are a couple of points of interest that we're looking to get rid of on this build. One, I don't want a bunch of articulated mechanicals sitting above the throttle bodies, because part of this whole effort is, as much as we like the sex appeal of carburetors, we can't get around the fact that fuel injection is just better in every way. So this is the process we're going with. The other thing is no matter what selection of carburetors you have, no matter how much power your motor puts out, those carburetors have chokes in them. They choke them down from, let's just say, 45s, which is what these are. These are true 45s. It's 45 all the way through the manifold and through the block down to the valves. In a carbureted car, you're going to have chokes back there. Not that that's a bad thing. They're essential because they're part of the horsepower and torque experience of those carburetors. But in this particular setup, we want to maintain that true 45 all the way down to the valve. Okay, and that's what we have achieved. Okay, and that's where our grunt power is going to come from. Now, with that said, here is the belt crank that sits on the throttle bodies. I realize you can't see it, but the advancing of the butterflies comes down to here. Now, this assembly is right here. The Spica's advancement arm for fuel is over here. So essentially, there's about 4 inches of difference in horizontal line. If I were to come across here down to the belt crank, I'm going to have an out of alignment ratio. In other words, the Spica is going to advance before it comes around to the height of the arm to pull the throttle bodies open. So if I can't pull the throttle bodies open in the same sequence as the fuel delivery coming off the pump, the car's never going to run right. So what are we going to do about it? The reason I have to put this together is because I've got to mock up relationships. So here's where it's at on the belt crank. All I'm going to do is fabricated tubing. It's going to come off of here and line right up to the arm here. That way, as this arm's advanced, it's in a true line. Granted, it's 4 inches over this way. It's in a true line with what linkage on the butterflies will experience. So when this arm's moving, so is the butterfly. It's a fairly simple process, and it's something we have to do. The other thing we're going to do is that in this car, instead of having linkage come through here to advance on the pedal, which would add another equation we're trying to stay away from, we're going to pull all this down from underneath. In other words, the cross member comes down around right here. We're going to mount where a cable pulls this down. That way all this stays in line, and it's one point of reference, which keeps everything in harmony and synchronizes the entire throttle advance experience. You'll see what I'm talking about in a few minutes. Okay, as we talked about earlier, that overcomplicated system in sort of just making the fuel injection system work in synchronization with the Spica system was simple to resolve. All we did is we took an old belt crank, brought it down this way, bent it up so the cable stop can rest, and now it's tied to one location, and it's a 1-to-1 ratio. That's the most important part. So anytime I'm advancing the fuel arm on the Spica pump, it is advancing the arm on the throttle bodies, all in the same motion, and it's very fluid. Okay, so it's a win-win all the way around. Now, with that said, obviously this is something that we have to work our way through, and we have to make it somewhat simple and consistent every time, because if it's an overcomplicated, articulated system, it's just going to have more inherited flaws in it. So that was relatively simple resolution, and you can see that we have the cool factor. It doesn't have the the Rube Goldberg throttle assembly like earlier you saw in the other car, and it is, by all intents and principles, it looks to be fairly simple to do. Now it's time to build this motor and get testing. Okay, so by now you've seen the motor that we're putting in this. It's going to be what we're calling the Quasi Ti motor. It's a high-performance speaker pump with advanced throttle bodies that look like carburetors, so it's kind of a win-win, if you will. Anyhow, we never did trust this motor because randomly and for no understandable reason, it would absolutely just blow the radiator all the time. So, with that consideration, with the suspect transmission, there's just nothing about this that we were terribly interested in using in this particular application. So we'll go through this motor at a later date and figure out what all that was about. Okay, it's one of the bigger challenges you have to deal with when you're doing this fuel injection conversion is you take nothing for granted. This is the throttle assembly from a speaker car. The reason that's relevant is because the rod goes up instead of down. It goes up, which pulls the cable back. If this was a carbureted car, it pushes the rod forward. So it's something you have to think about. So I'm taking all the stuff from a speaker car, which is that, and this, and making sure I have my locations where I need them. And there they are. So that's going to work out just fine. So basically what's going to happen is the cable is going to pull down, come up, mount to here, and be pulled back. It's one of those things, if you don't figure them out early, it could be a real nightmare to deal with later. Okay, so one of the last things we're going to do today is that we have pulled the old non-hydraulic pedal assembly out of the car, and thank goodness we have to have a couple of these. These are 69 only hydraulic pedal assemblies. What's relevant is this section right here. This goes through the sub rail, which goes to a hydraulic line which follows underneath the floor pan. So without this, you can't really incorporate this pedal assembly into a hydraulic setup very easily. This is the cleanest and simplest way to pull it off. However, 69 cars being exceptionally rare makes these pedal boxes even rarer, because you'd have to have 69 that has obviously met its demise to get one.